Doctor of Philosophy in Electronic and Communication Engineering. She's the first female lecturer in the Department of Electrical Electronic Engineering. And the first female HOD in the same department. By the grace of God, she is a 2-time Research Grant Award winner with the Nigerian Communications Commission. Her research area is not limited to her field, but extends to application of IoT in agriculture. She is open for collaboration with our sisters in the field of agriculture. Once again, we welcome you, ma'am.
Good afternoon, members of the High Table, honorable First Lady, and distinguished women in science. My name is Dr. Stella Olokwe. Today I'm just here to make a little presentation on the environmental impact of 5G technology on climate change. My presentation outline goes like this, starting with introduction. We're going to look at energy consumptions of 5G infrastructure. We look at greenhouse gas emission of 5G, the potential environmental benefits of 5G, and we will conclude. All right. As a word of introduction, we can't talk about 5G without looking at the history of mobile networks. If you look at what we have up there, we can see the first car telephone system. That was the telephone we have in the 40s. It simply means that only the rich can make use of telephone. As you can see that the telephone can only be installed in the car for you to move it. Alright? So fast forward to 60s, we have the handy talkie, which you can see up there, is still very heavy. And in the 1970s, that was when we have the first cellular mobile phone. When we talk about cellular phone, we are looking at having a cellular, segmenting the area in what we call cells. Okay, before the 80s, we have what we call the 0G technology. It was in the 1980s that we have the first 5G cellular phone that was used only for voice, and it was an analog system. Then fast forward to 90s, we have the digital phone, which was incorporated with SMS. You can send a little data, a little message, SMS message. And the difference between these two, the first G and the second G, is in terms of their speed. If you look at the first G, just like a baby that is crawling. And when you look at the second G, maybe the baby has started walking. Then before we have the third G, that brought mobile phone into the internet community, online community that you can use your phone to browse. Alright? And if you look at the speed, as at that time we now have, with 3G we can have up to 2 Mbps. And then fast forward in the 20s, 2010, normally after every 10 years, there's a rollout of a new network. So in 2010, 4G network was rolled out, which we call the LTE, or what we call the long-term evolution. And that has a high speed, very high speed compared to 3G. You notice that I believe that most of us are no longer using 3G phones. Because with 3G phone, it's difficult for you to even browse. Because of the speed, it's very frustrating. Okay? But from 2020, we now have the 5G. The 5G that brings telephone system into a real world application. Here you can use your phone even right here. You can be here and monitor what is happening in your house, even what is happening in your business. with 5G technology. So what is 5G? 5G represents a significant leap forward in mobile communication in terms of speed, capacity, latency, and connectivity compared to the previous generation of mobile networks. How does it achieve this? It achieves it by using what we call massive MIMO to enhance spectral efficiency, network capacity, and overall reliability of the network. When we talk about massive MIMO, in 4G, you must have heard about MIMO technology. 4G actually incorporated MIMO. MIMO simply means multiple inputs, multiple outputs. And this technology was included in the antenna section, a situation where you can use more than one antenna in your transmitter, and also more than one antenna even in the receiver. So that is what we mean by MIMO. But in 5G now, we have what we call massive MIMO. I want us to look at just this diagram. If you look at this diagram, you can see the one at the left. I know most of us are aware of, are conversant with that diagram, the one at the left. So if you look at that diagram, that is a base station antenna, a mast, with antennas. If you look at it, you see those ones that look like drums, and the ones that look like fluorescent tubes. Those are actually antennas. Those are the antennas in the base station. Then when we talk about massive MIMO, look at the one of them in the by right, which is the 5G, in introducing massive MIMO. If you look at it, it's just that thing that looks like a board. It's actually representing this antenna that we can see here, the one that looks like drum and the one that looks like a fluorescent tube. So then here now, they now use a lot of antennas. So many antennas, up to 100 antennas can be integrated in just one base station. And that is what we call massive MIMO. And with that, you see that, okay, if you look at, you see that you can actually, you can control the beam to a particular user. A beam can be steered to follow a particular user, thereby increasing capacity and reliability of the network. Okay? So other things we can talk about in 5G is the frequency. In fact, 5G uses high frequency millimeter wave, we call it millimeter wave frequency in gigabytes. The millimeter wave frequency is a high frequency. You see, millimeter wave frequency brings a good advantage because of the bandwidth and the speed, increase in speed and bandwidth, but not without challenge. The challenge is in terms of propagation and penetration through the physical object. Because this millimeter wave is a high frequency, in communication, that's what we call wavelength. So this wavelength is actually like looking at the physical size of this signal. And when at this high frequency, because the wavelength is inversely proportional to the frequency, the wavelength becomes so small, so tiny, that even the raindrop can block it. And because it's so tiny, it will be difficult for it to even penetrate the walls. The wall can absorb the wavelength. So because of that, that led to what we have, having dense network in 5G. Like if you look at this diagram, nowadays what we have around, we have the mast, like what I showed before. But in the near future, what we are actually going to have, if we are to fully implement 5G in Nigeria, is to have so many base stations around. Like this environment, we can have one base station, just cover this compound. And maybe City having another one base station. And IPS having base station. So you see a lot of base stations. Even in the mall, we can have a base station that is inside the mall. So that the base station is now closer to the human. And being closer to the human means a lot of things. It means radiation, increase in radiation. It means a lot of infrastructure is being going to the cost now. Because mountain infrastructure, new infrastructure is very expensive. And it means increase in energy consumption. And that is actually where we are looking at now in terms of climate change. Because this energy consumption is going to increase in temperature. because most of the energy that is being used is from the fossil fuel, which can add a lot of carbon dioxide into the atmosphere, right? So that is what we are going to see in the near future. Okay, I want to talk about beamforming. Beamforming is a signal processing technique that focuses the signal directly to the target. So you see that the signal can follow that target. That is why you can see autonomous car, a car that is driving itself. And this car is actually communicating with another car. It knows that, okay, in the next 20 minutes, oh, there's a car coming from this direction. There's another car, and it will be able to monitor it. And so we also talk about, okay, I said another point I want to bring up here is that 5G uses software-defined network, and that leads to its feature of network visualization. You find that in 5G, the base station itself can be able to reprogram itself based on the situation of things. Seeing that there are lots of audio loops, it can reprogram itself so that it will apportion a lot of lines, parts to that audio, so that it will also reduce latency. By latency, I mean the time it takes for point-to-point communication. Alright. So that will take us to our next point, energy consumption of 5G infrastructure. When we talk about 5G infrastructure, we are talking about every infrastructure, everything that has to do with 5G, starting from the base station. If we have assuming we have thousands of base stations, in these thousands of base stations, we have antennas. All these antennas, they contribute to the common footprint of 5G. We also have cables that link them together. We also have a lot of things, starting from extraction to manufacturing, even to the operation of all these equipment. And also we think about, in 5G also, we talk about because of the kind of applications that we're going to be using in 5G, we're going to using a lot of real-time applications. We need to install the data. For instance, you use sensors to monitor what is happening in your system, your farm, or whatever. And all these sensors are getting information. This information has to be stored. So you also talk about what happened at the data center, where this information from the 5G related applications are being stored. So all those carbons that are emitted at those places for both cooling and powering the servers and even the network equipment, all of them are counted as 5G energy consumption. Even the deployment of routers, switches, and other network equipment in 5G network contributes to overall energy consumption. Therefore, we can say that there is substantial energy input that is required to power the supporting infrastructures in operation of 5G. Okay, greenhouse gas emission of 5G. Directly, we can say that the gas that is emitted by the 5G technology is very, very low. But when you now look at the indirect connections, all the infrastructure that are related to 5G, you find out that the gases emission in 5G is very high. Finally, we are going to look at potential environmental benefits of 5G. Okay, so because of time, we have a lot of environmental benefits of 5G, starting from energy efficiency, smart infrastructures. We can have smart buildings where the devices can even on their own automatically switch on when necessary, thereby conserving energy. We also have application in precision agriculture, just as what you read. I think you mentioned it that I'm interested in IoT application in agriculture. All right, so we have a lot of application. You can use sensors, you can use drones, IoT devices, to actually monitor you, automate your your agricultural sector in all courtesy of 5G. Okay, we also have potential benefit in remote monitoring and telecommuting in terms of transportation. With 5G, you'll be able to monitor, the transport system. You'll be able to monitor, to decrease road congestion. For instance, so many people can be at home, even connect to what we are doing. It's not as if it's not happening now. It's happening now. But 5G permits us in low latency, just like a blink of an eye, which means that you can be at your home, you are confident that you are just part of the meeting, that your network will not affect you, right? That's okay. And we also have renewable energy integration in 5G, efficiency resource management also. And in conclusion, I want to say that while 5G technology promises significant advancement in connectivity and technology innovation, its environmental implications cannot be overlooked.
I've been hearing about a lot of like the negative effects of the 5G. So I would want to ask, what are the health implications of using this 5G network? And other, you not mention any negative thing about it. Can you just throw more
Actually,
light?
I said it. I mentioned that radiation. Because yes, and that is actually what we are talking about. Because the best that we're dying as a result of radiation, right? Although research has not really proven it that it can affect human beings, that the radiation from the 5G is too much to affect us. Although there are a lot of speculations in that area, but radiation actually affects.
One, I want to understand what the multi-ranks means. I looked at it, I didn't know that to connect it to biology or where I was hanging. I did speak on it. Then the second one is related to her question, the VP's question. She asked about when I saw the title, Impact. So I was looking more on the negative, but now more on the positive were presented to us. And you also told us that with the advent of 5G, we are supposed to go into the future to have more base stations. And I remember listening to research by students from occupational health and safety, where they looked at the environmental impact of running or operating base stations. So if we have base stations in their numbers, what does it hold for us in terms of environmental degradation? Thank you.
Like if you look at, I mentioned under the greenhouse gas emission about the impact of 5G. You see, all the things that has to do with 5G, all the infrastructures actually has a lot to do with the environmental impact in terms of climate change. Then in terms of the dense nature of the 5G, looking at it, this mast for 5G actually miniaturized, not just what you saw. You see, what you saw is the macro base station. We have micro base station. Base station can be in this room and you will not know. Yes, it's a micro base station. Even in a mall, you have base stations. And you will not know until somebody show you that this is a base station. Alright? So it has been miniaturized so that it will be close to us. So the essence of that is because of what I mentioned about the millimeter wave frequency that has been introduced in 5G. Because the millimeter wave frequency has the wavelength that is tiny in such a way that the signal, like here, you can make call, you can receive call. Because of the frequency we are using in 4G at the low frequency. So the frequency can penetrate the wall. But with millimeter wave frequency, the frequency can be absorbed by the wall. So inside the house, it might be difficult for you to receive call. That's why it has been miniaturized such that it can be installed even in house and everybody around can for more connectivity and reliability.
Thank you. Mine is just to add a voice to what she has said. Thank you for the presentation, Dr. Rakwe. That was a fine one, a good one. Professor Ikeria wanted to know how this base 5G affects the environment and what can we do to actually curb that impact. Most of the BTS we see, most of the base stations we see them running on diesel. Okay, and then when it runs on diesel, these carbon emissions are very high. So, but today, because of that, we are trying to look at ways of curbing down this emission by bringing hybrid systems that are eco-friendly and sustainable. One, using the solar, and then secondly, maybe using the other from waste, generate power from waste combined with solar. Then if it's an area that is very close to the river, we run also on hydro. So when the BTSs for the 5G, they have very small locations, we can scatter them around. So we have a central generating end that is hybrid, eco-friendly, that will power the different areas so that we can have self connectivity. So that way, we have less emission with the integration of eco-friendly, sustainable power supply. So we eschew, we remove completely diesel and all the emissions associated with diesel and run utility, which is NEPA, and any other hybrid source, solar or hydro, or that is eco-friendly. Thank you. Then the other one, because we have so many of the BTS around, it's also constituting some kind of heavy metals built everywhere. So how do we conserve them such that we don't have metals around? So they say best way is to try and go through pre-processing, reforming, rather than discard these things. We can get them together, melt, and then use it again to produce so that we don't litter the environment, we don't waste things, and then we use it again. Thank you.
Okay. We are taking one more question at a time.
Thank you, our presenter. Just to add to her voice, this there's a research I'm carrying out currently. We are trying to divert from emissions. You engineers, we are focusing mainly on emissions, and we are now looking at chemicals associated with all these gadgets. Like in my findings, I discovered that this poly chlorinated and brominated biphenol is emitted from this gadget. And what we are doing, scientists are doing, is to look for a substitute. Okay, if we say we have detected this congener is having a toxic impact on humans, they look for alternatives. And those alternatives are also, impacting into the what? Into the environment. So what I'm suggesting is that we are going for more convenient approach to this, which also look into the impact of the devices we are going for as alternative. Because these BBBs and PCB, we discovered that they've been bound years ago, but today we are still detecting them in human bodies, and they are causing a lot of harm. So that is my contribution. Thank you.
A child in the distance, playing in the rain, the sweet sound of water flowing away. A construction worker coming home from work, two parents and their children going to church. A happy little baby drools on your shirt. What an extraordinary day.